Problem number 59. We're given a solenoid with a large number of 1,000 turns and an overall length, this many turns over a length of 0.4 meters. We're told that the magnitude of the B field is 1 times 10 to the negative 4 Tesla at the center. And then we're asked to find the current. Okay, well, one thing we can do is look at the formula we have been given in the book. 1 over 2R, right? We don't know what R is, so we might want to switch to something very similar. But written a little differently, where N is going to be the number of turns per length, right? So here we have the number of turns per length, but we don't know what that is. What I'm saying is we don't know what the radius is, so it might be a little easier to use this version of the B field. So we know that we know what our B field is, right? Let's just write it out like this. 1 times 10 to the negative 4 Tesla. And then we'll take these things to the other side. We'll take this to the other side. We'll take this to the other side. So that's going to give us 1 over 4 pi times 10 to the negative 7 Tesla meters per ampere. And then we're going to have overall length over the number of turns. And that's going to give us our current that we're looking for. So if we plug all of this in, we end up with a value of 0.0318 amps. And we can rewrite this. A little cleaner version would be 31.8 milliamps, right? Because we usually will write amps, milliamps, microamps, nanoamps, something like that. It's a little easier to deal with. So that's our answer. Next, we're given another solenoid. A couple of problems are pretty easy. I wouldn't say they're easy, but they're more straightforward. That's really what I mean. So we're given another solenoid. We're given a bunch of information about it. This is the length. This is our magnetic field strength. This is our current. We're given a temperature. We're asked to find N. And so if we look at the formula that we wrote down before that we were not able to use, I think we actually just have everything we need here. Or no, we don't, because we do not have our radius of the solenoid. But that's okay, because we have another formula that we can plug in where we have n, little n, times mu naught times the current. This is going to be the number of turns per length times 4 pi e to the negative 7 Tesla meters per ampere times 75 amps. So to find N, all we have to do is solve. We have everything we need, right? This is B. I don't know why I wrote that down as equals T. This is 9 Tesla is equal to our B field. Right? Okay, good. So now we have L times B over mu naught over I. That gives us the value of N. And so we have 9 Tesla times 0.5 meters, just double checking that, over mu naught is 4 pi e to the negative 7. And our current is 75 amps. That should give us a value that we can reasonably use. So what did I get? I got 47,746.5 turns, or approximately 48,000 turns.